good day. I hope all is well. Okay, I've received, let's check here. Yeah, a lot of messages from students who are doing STTN124. Yeah, yeah, and I saw that most students are having problem with this chapter. I think it's study unit 7. Yeah, chapter 16. And please note that for those who don't, please note that chapter study 6, study 6 is already available on my YouTube channel, the one for contingency table. And another thing, the sad news is that I don't have the previous question papers. I only have the past tests. Yeah, I don't have the previous question paper. So I wish after maybe this session, I could maybe do 2024 question paper, explain some few things for you guys to see. Yeah, but another thing is that this chapter is not difficult, né? So I'm going to give you guys the strategy on how to tackle the thing. But I'll just try to check and ask my my other colleague who are student assistants for STTN124. So maybe they can send me the question papers before the end of the day. Yeah. Or maybe I'll just try to check the one for test 4. Yeah, I'll just try to check and see there. Okay. Okay, let's check the study outcomes for this. For the study outcomes, you need to understand the difference between what we call the parametric and also the non-parametric. So this whole chapter, it's about the non-parametric methods. So, but it's very important for you guys to understand the difference between the parametric and non-parametric methods of inference and also the use of the correct method. So I'll focus more on the calculations. I'll focus more on the theory questions. I'll focus more on the calculations. Okay, let's see. So here again, we are going to talk about what we call under the study outcomes. Let me just try to put this one. Let's see. One, this one. Yeah. Yeah. Okay, with this one, it says carry out the symmetric test. Some they call it the rank sign test in one simple case to test the hypothesis. So the aim here is to test. We're still going to use the same hypothesis testing steps. Step 1, you formulate the null and alternative hypothesis. Step 2, you specify the significance level. You also write the correct formula. Yeah, still the same steps. So here to test the hypothesis, where n, this thing here, this symbol, stands for the population median, the symbol. And if we use this symbol here, the one with 0, it means that it's constant. So yeah, remember this symbol stands for the population median. Okay, and again, we also carry out the rank sum test for the hypothesis where we are dealing with the 2 samples. This one is we're dealing with 1 sample, and this one is 2 sample case. When we're dealing with the 2 sample cases for the independent samples, where the population median 1 will be equal to population median 2. Okay, let's just look at maybe examples. Let's see. Okay, so we're going to talk about the parametric methods and also non-parametric and other statistical methods. Let's see. So remember, I told you that I will focus more on the calculations. So I won't be able explaining the theory questions. So you can just on your side look at the things. So we'll be looking at the one for 1 population and the other one for 2 population. All of them. I mean, the one for 2 populations, it's under independent populations. Let's just look at the one for 1 population. This is the median. Eh? You guys, you did, I think it was study unit 4 from STTN124. It's the unit 4. I believe you all know how to calculate the median, ne? But here, in this case, ne, you can, like, just looking at this, I think you also did that thing of negatively skewed. It's symmetrical when it's here at the center, and positively skewed like this. But we're going to focus on that one. So here we'll be dealing with the sign test, on how to calculate the test statistic, how to formulate the null alternative hypothesis. Here, we will start with the sign test. Here, let's look at the one for the sign test. Here they say that the test is based on the population median, which is this symbol here, as a measure of the location instead of the population mean. So instead of us using the population mean, we're using the population median, as, remember, this symbol here. Okay, let's see. So especially they say that, especially in conditions where it is known that the distribution of the variable studied is skewed. Okay, let's see. Same steps. Step 1, you formulate the hypothesis, the null and alternative hypothesis. Step 2, it's when you specify the level, the significance level as alpha, and also write the correct formula, the test statistic. Step 3, you calculate the test statistic and also the critical value. Meaning, there's a table that you guys are going to use. Right? I'm going to explain that in a later stage. Step 4, it's when you state decision rule. Then step 5, you make a conclusion, you interpret, then you also draw conclusions. Let's look at the example. Okay, let's see. Here's the example. They say that, suppose it has been established by experimentation that the median reaction time of an individual under specific conditions is 0,250 seconds. Okay, this is the value of the median, that symbol. I think it's something like, just erase this one, something like this. Yeah, something like this. Yeah, that value. So they say now the individual now consumes a quantity of alcohol in a series of 12 trials. Think if you, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 trials, ne? Is carried out to determine the reaction time. The observations now are provided below. Here are the reaction time. Ne? Reaction time. How will you test whether the data are consistent with a median value of 0,250? You must use alpha is 5% as 0,05. Let's see on how to tackle this whole thing here. Now, when we look at this, the steps are still the same thing. Step 1, let's formulate the null and alternative hypothesis. Let's see. Remember, this is very important. You all remember when we're dealing with hypothesis testing that with hypothesis testing under the alternative hypothesis. Don't worry about the null hypothesis, because the null hypothesis, we always use equal sign, equal sign, equal sign. It's when now you just say, okay, the null hypothesis where population median is equal to that value. But you need to be careful. Look at the symbol of the alternative. Remember, alternative, it's either you can use less than, depending on the question, greater than, or you can use this. Something two-tailed, two-sided. It's a two-tailed test or two-sided. So here it's left-sided, it's less than. They use less than. Here it's right-sided. They use greater than under the alternative. So here it's two-sided. So they use this symbol here, this one. Okay, let's see. All right, let's see. Here, step 1, when now we're looking at that question, when they formulated the null and alternative hypothesis, let's go back to the question and see, under the statement of the alternative hypothesis, the reason why they used that symbol of the two-tailed test or the two-sided, this symbol here. The reason why they used this. By looking at this statement, there's no a statement or a sentence where they mentioned left-sided, right-sided, they mentioned greater than, they mentioned less than. So it means that we would assume that it's two-sided. You all remember when I was explaining, there was this video that I sent. It's available on my YouTube channel, where I explained this whole thing of the two-sided, the left-sided. How do you see when you're given a scenario or on the statement? How do you see that this thing is less than, greater than? They will give you a hint there. So here, this statement, by looking at this, it's two-sided. This is two-sided. So remember the value there, this value here of the population median, it was 0.25. And you know that 0.25 is the same as 0.250. 0.25 is the same as 0.250. So here, this is how you formulate the null and alternative hypothesis. Here. Now I believe you all know the reason why they used this symbol here. Okay, let's go to step number 2, when we specify the significance level and the test statistic. Already the significance level were given, it's alpha as 0.05. And what about the test statistic? Let's see. Before we look at the part of the test statistic, we have what we call the B. The B is the number of the x's, the x that are larger than the population median. The B, the number of x that are larger than the population median. Our population median, it was 0.250. And we're also given the reaction time. So we're going to check the values that are larger than the population median of 0.250, looking at the reaction time. Let's see. Let's see. Let's see. Okay, this is how you do it now. Let's see. But before that, I will just come back to this one. Let's see. To this one here. Okay, but before we look at those values that are larger than the population median, here, when we assign the observation, e.g., like plus or minus, it's when we are going to compare those x values or the reaction time values with the population median of 0.250. Okay. I think I already explained this one, that you are going to check the values that are larger than for us to find the value of P. Let's see. Here, this is how you do it. Agree already with regards to the significance level, on how to specify the significance level. The to specify the significance level, already we are given as 0.05. So this is how we do it. We are going to check. This is very important. Remember, to get the value of P, we look at the values that are larger than the population median. Our population median is 0.25. So those values that are larger than population median, we will assign those values as plus. Then the ones that are less than, we'll assign them as minus. Then now, to get the value of B, it's when we are going to start counting the values, the ones that they were assigned as plus. How many values? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and so on. So let's check. 0.250. Obviously, 0.235. It's less than 0.25. That's the reason why it's minus. 0.252. It's above 0.25. That's the reason why it's plus. That's the first value. 0.312, firstly, it's above 0.25. It's plus. Second value. 0.264. It's above 0.25. The third value. 0.32, obviously, it's above. Fourth value. 0.241, it's less than this value. It's minus. It's out. 0.284, yes, it's above. 306 above. 248 is less than this value, minus. 284, it's above. 298 is above. 320. Then we start to count. 1. Now here it's 4. 4, 5, 6, 7, 8, 9. The value of B will be equal to 9. Let's see. The value of B will be equal to 9. We're looking at the values that are larger than the population median. Okay, let's see now. Now, we got the value of B. We know the level of the significance as alpha is 0.05. Now we need what we call the critical value and the decision rule. This is very important. Look at this. We say, now I believe you know how to formulate this whole thing. To formulate this. You know how we formulate this. We check. We reject the null hypothesis if that value of B is less or equal to the n minus B, where it's n and also alpha. I will explain this whole part. What does this mean? And then again, we reject the null hypothesis if the B is greater or equal to the B, N, and alpha. I'll also explain this part here. Again, we reject the null hypothesis if B is less or equal to N minus B, like this, or B is greater or equal to this. Let's see when we get there. When we use the example. N, we know that it's 12. When we count the reaction time, we were also told that N is equal to 12. Alpha we're given as 0.05. We're also given, this is very important. The question is, when we're formulating the null and alternative hypothesis, we said under the HA, remember, don't forget this, we said under the HA that it's like this. It was that value there. We use two-sided. Why? Because when you look at the scenario, there was no sentence or a statement where they were mentioning that this is left side, this is right sided, greater than, less than. That is why we had to use the symbol of the two-sided or the two-tailed test. This is you need to be careful of this. Now, the alpha, it was 0.05. We were given they were provided with the value of the significance level as 0.05. So we're going to say that since it's two-sided, we have to divide by 2. We have to divide our alpha by 2. Right? Our alpha by 2 because it's two-sided. So what is our alpha? 0.05. So 0.05 divided by 2, you will get 0.05 divided by 2. You'll get 0.025, this one here. Now, this thing, now I'm explaining this. What does this thing stand for? This whole thing here. Now, we know now here, Uguti, it's B, N. Remember, according to this, look at this. N and alpha. But our alpha now will be 0.025 because of the two-tailed test or the two-sided. And it's 12. We're given N. This here, it's 0.025. So now, N is 12 minus, where does this 10 come from? This whole thing here, we're going to use what we call this table here, the table for the critical value under the non-parametric value, the sign test. This is what you do. The N here, you will be, I think you guys will be provided with the table. The N is 12 here. That's the value of the N. Here, the now, because it's under the two-tailed test or the two-sided, we said 0.025 divided by 2, and the answer you got 0, you said 0.05 divided by 2, and then you got 0.025. You just go this side, 12 correspond here, you'll get 10. This whole thing now is 10. Therefore, now you say 10. Therefore, it's going to be 12 minus 10. You get 2. That's how you get this whole thing here. Yeah, that's how you get this whole thing here. So it's very important for you to check the statement of the alternative hypothesis. Okay, let's see. Continue. Let's see now. We said we reject what? The null hypothesis if the value of B is less or equal to N minus B, this thing. Now you saw how they got this. This whole thing here, it was 2. Ne? This whole thing, it was 2. Okay, let's see. So the value of B, let me just check something here. Now you saw how they got this here, this thing here. You know how they got the value of B. I explained that it was equal to 9. You also know how they got N minus B, this whole thing. They got 2. They got 2. It's either you can use this one or this one. But I will advise you guys to use this one. It's still fine because it's still the same thing. You saw how I got the value of 10. I explained how they got the value of 10. So we said we reject the null hypothesis if the value of B, this 9 here, is less or equal to 2. But if you check, or we can use the one where we say that the value of B is at least 10. So let's try to see. This is the value of B here. So here, let's go back here. This whole thing is equal to 10. So we say that thus we reject what? We reject HO if the B less or equal to 2. Ne? Or the B is greater or equal to 10. So when they say greater or equal to 10, it's at least 10. So it's 1, 2, and 3. And then the B is less or equal to 2, according to the rule. It's 1, obviously, like the values that are less or equal to 2. 1, 2, 3, 4, and 5. So that's how you state the decision rule. That's why you say that you reject the null hypothesis if the value of B is less or equal to this value. You know how they got the value of 2, this one 2, and the other one of 10. So yeah, and then after, therefore, now we make our conclusion. We make a decision and we draw conclusions. Now we say, now we do not reject the null hypothesis. This was just a statement that we can only reject if the value of B is less or equal to this. But now, when we make a decision and also draw a conclusion, we say now, we do not reject the null hypothesis. Why? Because the value of B is greater than 2. You saw how they got the value of 2. The value of B is 9. So obviously 9 is greater than 2. So therefore, it's not under that condition of the B. We say that, let's look at this so that you can all see what I'm talking about. This is very important. Remember, we reject the null hypothesis if the value of B, the value of B is it was equal to 9. And this whole thing was 2. And it's not possible that the 2 can be bigger than 9. No. And now, look at this. If here, there was no part of the do not reject. Obviously, it's going to be like, if we say that we reject the null hypothesis if the value of B is less or equal to n minus B. And when 9 is less or equal to 2, and 2 cannot be greater than 9. Obviously, 9 will be greater than 2. So therefore, we fail to reject the null hypothesis. It's what's happening here. Look at this. Look at this. It's that thing. According to when we make a decision, because we're looking at the value of B as 9, we're also looking at the value of this whole thing, that one here. 2, you know how they got 2. B, 9 greater than 2. And 9, and then you say less than 10. So the bigger one will be this one. You can just choose if you want to use this one or this one, but it's still the same thing because you know how they got 2, you know how they got 10 on that table. So therefore, we say that we do not reject because B is greater than 2. But if, let's say, for example, the value of B, when we're counting those values that are larger than the population median, if, let's say, we got maybe 1, then we were going to say now we will reject the null hypothesis. Yeah. So therefore, our conclusion will be like, since we fail to reject the null hypothesis, therefore, not enough evidence or a proof to indicate that the reaction time is significantly different from that median of what? Of 0,250 or 0,2, like this. So yeah, that's how you do it. Where's that thing? Let's see another thing. If you are given X value that is equal to that hypothesized value, which is the population median, then that value is removed from that sample, meaning now the sample size will do what? Will decrease. If you are given the X value there on that reaction time, that is equal to the hypothesized value. I'm sure what they're talking about. The value, it was 0,250 or 0,25. They're saying that if you are given X value here, that is equal to that hypothesized value, we remove it, and then obviously the sample size, instead of 12, it will be 11. It will decrease. I think that's what they are trying to say. You see that the sample size decreases accordingly. So yeah, you can try this one. Remember here, it means that the population median will be equal to, okay, consume no more than 70. But now, it's very important now to check. You see on this one, they mentioned more than. So it means that under the statement of the alternative, you're going to have something like greater than, because it's more than. And when it's more than, it's not two-sided. You're not going to divide the significance level by 2 because it's not two-sided. So yeah, try this one out. And also, for you to check the value of B, you're going to check the values that are greater than the population median and see like how many values. Then you get the value of B. Then after you go to the table, you also get the N minus B and also the alpha. You just do that, you compare. You see that if this one is it's at least that the other value of the critical, therefore you reject. But if if it's less or equal to, you reject. But if it's greater than, then you fail to reject the null hypothesis. Yeah. Then yeah, that one it was for one population. I'll just try to check if I have maybe the questions that are based on the non-parametric methods. If there are students who have maybe 2024, 2022, 2021 the exam question papers, please send them to me and then I'll just try to do maybe 30 minutes or 35 minutes or maybe 40 minutes video and then explaining the questions that are based on the non-parametric. But also check out this one there. I will upload it soon after download it. Maybe I'll just upload it there. Then now we're on the 142 population. You saw the 141 population, how they ask questions. Now the 142 populations, we'll be dealing with the independent populations. Let's see. Okay, let's look at this one. Interesting. This is interesting, this one. The Wilcoxon rank-sum test. Interesting. Still the same the steps. Same. Formulate the hypothesis, specify the significance level, then the test statistic, calculate the test statistic, and critical value. After you state the decision rule, you make a decision, interpret, and you draw the conclusions. Now with this one, this chapter is not difficult. Now, this is very important. You saw that the one for the sign test, we're dealing with the one population. You saw that they used to say the population median is equal to the certain value of that median, population median. Maybe that one you are saying the null hypothesis where the population median is equal to 0,250. And then on that scenario, it was the alternative hypothesis where the population median is not equal to 0,250. Now we are dealing with the two populations, population A and population B. It's what you call I think the WILKOXON, something like the rank-sum test. It's interesting, but you need to get what you call the ranks and so on. But I'm gonna show you one step at a time. Yeah, this chapter is interesting. Look at this. We'll give an example. It says that a comparative study was carried out on a 15 patients suffering from some neurological condition. Okay, 7 of these under group A, they had an operation to improve their general condition, but which might have affected their speech. Interesting. Let's see. Now, the hypothesis we need to test is thus HO, where population median 1 is equal to population median 2, versus the alternative hypothesis where population median 1 is greater than population median 2. Use alpha is 0,05. We are given our sample data, A and B. Let's see. Step 1, already you saw how they formulated. Even this one, just that the difference is that now we are dealing with the two populations under the independent samples. We are also using, under the null hypothesis, you always use equal sign, but the alternative, it's either you can use less than, you can use greater than, you can use not equal to. How do you see? They will mention, you will be given a hint that this population is greater than this population is less than this population. And if they don't mention that this one is greater than this one or this one is less than this one, you're going to use the two-sided or the two-tailed test. Okay, let's see. Already you saw how they formulated this one. We were given there on the statement. Now, we need to specify the significance level and the test statistic. Now, for the test statistic, we have our new formula to calculate the test statistic. Now, you saw when I was explaining the one-for-one population, we didn't have this the whole thing of the test statistic formula like this one. On that one, you were finding the value of B. You know that with the value of B, you look at the values that are larger than the population median values, like direction time that will be given there. Not only like you'll always be given direction time values, but you will always be given you saw on that exercise that I said that you guys can try it out. That one, you'll be given the values. You're going to compare. This one is like that. This one, you take those values. Then you formulate that. Oh, this one will be the value of B. Now here, that one, it was the sign test. Meaning with the one population, we're dealing with the sign test. Now we are on the two population. We're dealing with the Wilcoxon rank sum test. This is the formula that we are going to use here for the test statistic. Okay, let's see. Let's see. One, you need to assign the ranks to the combined sample observation, the lowest one. Okay. Now, after you determine the sum of the ranks of group A, as like this one. Usually, they use the smallest sample. After, you can calculate the test statistic. You might think that this is difficult. Then after, you can determine the critical value of the test. Let's see. You might think that this is difficult, but it is not. Let's look at this. We're given sample A. We're also given the sample B values. Now, they were finding the ranks of A and the ranks of B. When you look at some of the values from A and B, their ranks are the same. You know, that's what I'm saying this. Let's look at where the ranks are the same. Let's see if we do have the values where the ranks are the same. This side we have 5.5, and this side we only have 5.5. It's 12.5. Oh no, what I'm saying is that you see under we have 2.6, 2.6. Their ranks are the same, 12.5, 12.5. And even here, 2.5, 2.5 is 10.5, 10.5. Even here, 1.8, 1.8 is 5.5. How did they get those ranks? How did they get those ranks? Interesting. Let's see. This is how we do it. You need to be very careful with this, with the method. Let's start. Let's try to increase the thing and put rate. Here, under A, this is our data. Under B, this is our data. We're going to start. The first, I'm just maybe change the color. Here, the first value, this is what we do now. We have A and B. We're going to combine our data into one thing. We are going to combine our data into one thing. After combining the data into one thing, we ascend our data in ascending order, meaning the first value will be 1.1 as the minimum, and the maximum will be 3.0 as the maximum. Ne? But don't forget that this, look at this. Ne? Look at this. The first value, it's 1.1. Ne? We know that 1.1 it's under rank A, but now what we are doing, we combine the values into one thing. We know that we have two observations, A and B, ne? As our two populations. Let me just say two populations, A and B. What we are doing here, we are combining the values. We make it one data set. We group that data in ascending order, ne? The first one is 1.1 followed by 1.2. Let's put it like 1.2. Do we have 1.3? Yes, we do have 1.3. How many 1.3 do we have? It's only, wait. I want to see something here. It's 1.3. Oh, two 1.3s, 1 and 2. Yeah. So it's 1.3 again. Just write them the way they are. Ne? Do you have 1.4? Nope, we don't have 1.4. Do you have 1.5? Nope. We do have 1.6, 1.7, and 1.8. 1.8, 1.8. 1.8 and 1.8 like this. Now, do you have 1.9, 2.0? Yes, we do have 2.0 there. I just want to verify if maybe. Yeah, we do have 2.0. We have 2.1. I think, let's see. That's why I'm saying you need to be careful when you assign your data in ascending order. No, we don't have 2.1, but we have 2.2. Okay. Where is it? So we have 2.2. Do we have 2.3? How many 2.3s do we have? It's only one. Do we have 2.3? Yes. Do we have 2.4? No, we don't have 2.4. Do we have 2.5? Yes, 2.5. 2.5, two of them. 2.5 and 2.5. Okay. Do we have 2.6? 1, 2, two of them. 2.6, 2.6. Do we have 2.7? Yes, 2.7. Yes. We have 2.7. We have 2.8. I saw it. Do 2.8. No, we don't have 2.8. We have 2.9. No. We have 3.0. 3. The last value. Now, before you, the method I'm going to give you, just try to count if, let's go back to, let's just count them. This side, it's how many values? 1, 2, 3, 4, 5, 6, 7. I think I saw 2.5. Okay, 7. This side is 1, 2, 3, 4, 5, 6, 7. 14, 7, 7, 14, 15. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. They're grouped. But don't forget, Uguti, after finding the ranks, if I find the rank for 1.1, I know that 1.1 is under data A. Ne? This is what we do now. I'm going to try to put this one here. Now, here, we're going to have what we call, but let me just put it here. Maybe put it here and take this. Okay, take this and put it here. Okay, can I put it at the back? Let me try to start this whole thing. So what I'm going to do here, it's what we call the position of the rank. Here, the first position, it's 1. I wish I can just maybe change the color. I change the color and maybe let me just try this one. Try this one out. Let me put this one here and put different color, maybe blue. What I'm writing here, let me write it here. The position of the rank. Ne? Let's put it here. The position of the rank. So the first position, it's 1. Before that, what happens if you have 2 values or 3 values? You can even have 4 values that are the same, that are repeating. Maybe you saw that we have 1.3, 1.3. And all of them, 1.3, 1.3, they have a rank of 3.5. How do they get 3.5? This is what you do. You saw that step number 1, I combined all the values and put like as one data, and I grouped that data into ascending order from the smallest to the largest. Ne? Now, this is what you do now. After doing that, you will now write position 1, 2. I'm up until position 15. Was it 15? Yeah, 15 there. Position 2, 3, this is 4, and this is 5, this is 6, this is 7, this is 8, 9, 10. You'll never go wrong by using this method. Trust me, you'll never go wrong. This is 11. This is 12, 13, 14. Then number 3.0, it's 15. That you won't be able to. But look at this one here. This is 3.0, ne? Yeah, 3.0 there. Now, this is what you do. Now, let's change your color. Step 1. Group your data set into ascending order. Combine everything into one data. Group it in ascending order. That's not step number 1. Ne? This is step number 1 here. Step number 2, write down the positions. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till 15. Again, we have 15 values. Now, this is very important. Ne? If you have a value and that value is not even repeating, you don't have two values that are repeating, like 1.3, 1.3, only like 1.1. 1.1, it's on position 1. We're just going to assign it as 1 here. It's going to be a rank 1. 1.2, it's on position 2 and it's not repeating that we don't have another value as 1.2. Two values, actually 1.2. So 1.2 is on position rank number 2. We write it down. Obviously, we're going to write maybe something like a tables. That's the reason why I'm saying that just follow the steps. You'll see even maybe in the exam, even when you do the previous question papers for those who do have the previous question papers. This is not difficult. Just follow the steps that I'm giving you. You saw that the sign test is not difficult. Use those explanations. Even this one. Now look at this. On position number 3 and 4, we have 1.3, 1.3, 1.3. What do we do if we have this? Do this. It's going to be 3 plus 4. Ne? How many values do you repeat? 2. Divide them by 2. What if here on position number 5, we had 1.3 again? We're going to divide by 3 because we repeated 3 values. So, but now it's only 2. It's 3 plus 4. I'm adding what? My position. Ne? I'm dividing them by 2 because it's only 2 values that are repeating. 3 plus 4, it's 7. Ne? And 7 divided by 2. So 7 divided by 2 is 3.5. So where I see 1.3, I'm going to put 3.5. This will give you 3.5. Ne? 3.5. So where I see 1.3, 1.3, I'm going to put 3.5. Where is it? Here it is. 1.3, 3.5. 1.3, 3.5. Maybe some of you guys are asking yourself, how did they get these values? Now I'm done. 1.8 here on position number 5 and 6. It's repeating twice. Ne? So what I'm going to do here, I'm going to do what? 5 plus 6 divided by 2. 5 plus 6 divide this whole by 2. So 5 plus 6 is 11. Ne? And 11 divided by 2, it's what? It's 5.5. So where I see it's 5.5. So where I see 1.8, I'm going to put 5.5. Here it is. 1.8, 5.5, 1.8, 5.5. Again, don't forget, again, I grouped my data set into one thing. I just put everything one to one data. Don't forget that we have a data, we have a population A values and population B values. So obviously 1.8 and 1.8, they fall under population B. So yeah, and then now it's 5.5 here. Where you see 1.8, 1.8, you put 5.5. But when you look at 2.0, it's not even repeated, but it's on position 7. You just put a 7. Here it is, 7. What's the other one? Now 2.2, it's not repeating, it's on position 8. Where is it? Position 8. 2.3 is not, even 2.3 is not repeating, it's on position 9. Here it is, position 9. And then 2.5, it's repeating on position 10 and 11. You do the same thing. You just say now, you add the positions. Ne? You say 10 and then plus 11, you divide them by 2. Remember what I said? If here there was 2.5 on position 12, we're just going to say 10 plus 11 plus 12. Because it's 3 of them that repeat, you divide them by 3. If you have 4, you divide them by 4. So because now you have only 2. 2.5 on 10, 2.5 on 11. So it's 10 plus 11. It's 10 plus 11, which is 21. And then 21 divided by 2. you will get 10.5. Let me just put it here. You get 10.5. 10.5 here. 10.5. 10.5. So where you see 10, where you see 2.5 and 2.5, you're going to put 10.5. Here it is. Where's 2.5? 10.5, 10.5. Now we are done. 2.6, 2.6, they're repeating on 12 and 13. So we do the same thing. Let me put it where? Here. It's what? 12. Two of them again. So 12 plus 13. 12 plus 13. You divide the whole thing by 2. So 12 plus 13 is 25. So 25 divided by 2 is 12.5. So where you see 2.6, 2.6, I'm going to put 12.5. Here it is 2.6, 12.5, 2.6, 12.5. The other one is, so I got this one. 2.7 is not repeating, it's on position 14. So 2.7, 14. 3.0 is not repeating, it's on position 15. Here it is, position 15. You see how you just get the ranks of A, the ranks of B. That you do it like this. Follow these steps. Okay, now let's see. Now, here, you saw how I got the ranks of A and also how I got the ranks of B. I think they made a mistake. It was supposed to be. Because if you check here, this is the ranks of A, this is the ranks of B. Till 3.5, the ranks of B. Yeah, the ranks of A, the ranks of B. Okay, now check this. Now, to get the summation, here, to calculate the test statistic, the summation of this N1 is the values of population A. We had 1, 2, 3, 4, 5, 6, 7. It was 7, N1 values. 7 into 7 plus 1 divided by 2. Ne? Here it is. I hope you understood this part. This one. Ne? Look at this one, the summation of Ri. Let's go back to this so that you can see. Determine the sum of the ranks of group A, usually smallest sub. This is very important, smallest sample. So we're going to compare between population of A and population of B. Here we 1, 2, 3, 4, 5, 6, 7. So N is equal to 7. Here it's 1, 2, 7, 8. Here it's 8 under B. So we say that we take the sum of the ranks, the one the smallest sample, which is we're going to take the one for A. That's the reason why this the whole thing here L under A, in L under the ranks of A. Here it was supposed to be the ranks of B. L under the ranks of A. Here. Let's try to see how it's valid. They got 68. It's 12.5 plus 7 plus 1 plus 14 plus 10.5 plus 12.5 plus 10.5. Well, it's 68. You saw how they got. Once you get this 68, you just go to here. You say 68 minus this whole thing. You get the test statistic as 40. You see, just follow the steps and trust me, you'll see that this is interesting. Remember, once you get the ranks of A, here, remember they made a mistake. You're supposed to be the ranks of B. Here, you're supposed to be B. Once you get the ranks, now, the minute you think about this, think about, oh, for me to get the sum of the ranks, either A or B, that population that you'll be given, I must look at the one with the smallest sample, and then you take that one. Here it is. And I think I explained how they got the ranks, the one for this. Just do this, use this method. Now you saw how you got the test statistic. Another rules, critical values, addition rule. I believe now you know how to formulate this whole thing here. Let's look at this. You reject the null hypothesis if this thing, it stands for the test statistic, This thing here, it stands for the critical value. I'm just going to put CV. It stands for critical value. We reject the null hypothesis if the test statistic is less or equal to the critical value, where the critical value is N1, N2, the level of significance. It means that, remember, N1 is the sample year population A, N2 is the sample year population 2, B. On A, it was 7, on B, it was 8. And then you look at also the alpha, the level of significance. And please be careful of this. It's very important to check if the decision, if the alternative hypothesis is we are dealing with a two-tailed test, it means that it's going to be alpha divided by 2, what they are doing here. That level of significance divided by 2. Another thing is you reject the hypothesis if the test statistic here, the T, is greater or equal to the N1, N2 combined minus the critical value. But you can also use this one. Let's see. Even this one, you're going to use a table. What is N1 under the population A, 7. N2 under population B, 8. The level of significance alpha we're given, it was 0.05. Now, it says W here, N1 here, N2 here, lay alpha. Remember, this whole thing stands for critical value. Critical value, ne? The reason why it's only alpha, not alpha divided by 2, because of our statement, they mentioned more than. It was population median 1, yeah, population A is greater than population mean, yeah, B, or 1. So yeah, that's the reason why it's only alpha. We don't have to divide alpha by 2. We'll go here. Or is it? It's N1 and N2. N1, it was 7, ne? Here. N1 is 7. N2 is 8. So 7 and 8. Alpha is 0.05. The corresponding guy, you go this side, you look at this one, you go this side, is 7 again. N1. Let me just wait. Yeah, N1. Because under population A, you go this side. They correspond, go 13 here. Go 13. Therefore, the critical value will be equal to 13. It's either you can use this one or where N1 is 7 multiplied by N2. Yeah, 8. So 7 multiplied by 8 minus here. This one is 13. So it's 7 multiplied by 8 minus 13, which is 56. You can just choose if you want to do it this way, meaning we'll compare 40, ne? 40 ling le 13. Or we'll compare 40 ling le 56. Only was 40 cannot be greater than 56, you see? Or 40 here. The 13 cannot be greater than 40. So you can just choose. So now our decision rule will be like, okay, now we're going to compare 40 with what? With the thing. Let's see. You saw how I got this one. Even this one explained. Now, here, test statistic 40. The critical value, remember I said you can use the one of 13. But now when you look at this, they got 43. I got 7 multiplied by 8 minus 13. Why on that one they said they got 56? Something. 56 minus 13, yes, 43. 43. So now we're going to compare 40 with 43. Check. Are we going to use the method where the W of the test statistic, is it less or equal to the one for the critical value? This is 40. This is 43. This is 40. Ne? This is 43. Let's look at the decision rule there. This one. This is 40. This is 43. The bigger one is which one? It's 43. Or you can use the one at 13. Yes. We have two conditions. Either you can use this one where this whole thing is 13. You saw how we got 13. Here it is. This whole thing is 13. So this whole thing now will change. Because now, it's like now, it's either, we say that critical value, the one where we got 13 critical value, or the what is the thing? The test statistic that is greater or equal to the critical value again, yeah, under condition number 2, the one where you got 43. Here it is. You can just choose. All of them, they will give you the same answer because now 40, the 13 cannot be greater than 40. Obviously, it's out. And also 40 cannot be greater than 43. So therefore, we're going to take this option out. We do not reject. Why? Because 40 here, 40 is not less than this one. Say this one here. The answer will be we do not reject because none of this whole thing, yeah, feed no. Because now, if we use this, 40 cannot be greater than this. But this is just a statement. But the conclusion, when you make a decision and when you draw a conclusion, will be like, we do not reject HO because this one will be 40. Will just, the whole situation will change because we cannot use this one of 40 less or equal to 13. No, it cannot be to one or one. So we do not reject the hypothesis. Therefore, the minute we say do not reject, there's no, we don't have enough evidence or not enough proof that the patients from group A experience is greater than the one for, I think, group B, or speaking with culture. So yeah, this one, exercise number 2. We have A, we have B. It's like when we have A and B, not exposed under A, exposed under B. You do the same thing. Group it, make it one data, and then you just group in ascending order, the smallest to the largest. Then you find the ranks. The way I was explaining it. Then you just compare it. You find the critical value using the table. N1, N2. Yeah, the way just try this one and see. Yeah, I think that will be the end of the video. Please don't forget to like and subscribe to my YouTube channel so that you can be able to see more videos of STTN124. Go.